So, hi, this is Metaclasses and Decorators in the Wild. So if those of you standing in the back didn't mean to come to this talk, it's okay. So my name is Silas Ray. Oh yeah, that. Hi, everyone. Should know about that, considering I've been going to the events for like 2 years now. But anyway, so that's my GitHub. That's my work email. That's my Twitter. I don't really Twitter, but it's there. So what I'm talking about today is a small library I wrote at work. So as it says, straight out of prod for the obligatory pop culture reference there. So I just wanted to talk about something that was somebody got it. Or appreciated it at least. So I just kind of, you see a lot of things on the web for metaclasses, and it's either like, hey, why don't you go look at Django and look at these 50,000 lines of code and sort of suss out like the little piece that you're interested in, or it's like a little toy example. And I kind of wanted to find something that was, we are actually, as it says, using this in prod, but it's still like small and sort of digestible enough and self-contained that it would be kind of interesting for people to look at without being distracted by lots of other things they're not really interested in. So that's where the project is. You can go there, you can grab it, you can run it. There's only been one line of code changed. One line of code? Yeah, one line of code changed since I copied it out of our product repo, so go for it. So Triplement, we are a New York City real estate firm. So if you're looking for a place, rent, buy, whatever, really those are the only two options. Sell, we do that too. You can come and we'll help you do that kind of thing. We have a customer-facing search site and a back-office platform for our agents to sort of manage the purchase process. So to service that, we do a lot of retrieving of data from different sources for all our real estate listings. So when I started there, January, one of the first projects I worked on was to write a new one of these data ingesters. And I kind of wanted to sort of revamp the underlying system because this is kind of something we do a lot. So I kind of decided to sort of approach this a little more systematically. So when I was writing the system, this is kind of the thought process that was going into how I was designing this thing. So if you think about our process, we have a bunch of remote sources, right? We write a client that iterates through, or that produces an iterator that is composed of the records from that remote source. Those records then go into what the FeedEater library through a translator layer that is for data extraction, and then a model proxy, which is for data normalization, and then into the database. So I kind of wanted to split up the flow control component from the data manipulation component, and then also split up the extraction logic from the normalization logic. So we kind of got maximum code reuse. We didn't have a lot of sort of drift between our different ingesters, so that if you kind of knew how one worked, you knew how all of them worked, and they didn't sort of change over time and become a pain. So the little toy example on the GitHub repo to sort of exercise this code, it's just around sort of very basic person records. So this is just the example of a little JSON format for people inputs and a CSV, and then in this particular system, just because I wanted it to be all standard library so you didn't have to go and download whatever, the storage mechanism is just a bunch of flat files with space delimited fields. So that's what that is about. So the model, again, super simple. We just have first name, last name, location, and profession. And then, as you see, the file path is just constructed out of the first and last name. So pretty simple stuff. So the first layer is the proxy. So this is the normalization layer. This is where we take the data that we've already extracted out of the remote sources, and we normalize it. So the normalize name function you see here, all it does is uppercase the first letter, lowercase the rest. So the proxy layer sits in front of the model, and well, obviously, its other responsibility too is to be able to actually get the correct model. So either to load the model or to produce a new model. So that's what this is doing here. So you see I just set first name, set last name, and then I'm just calling the load method on the underlying model. And this is the underlying class from which the proxy derives. So you can see the entire magic of it is just the underlying model. There's a setAttr and a getAttr that proxies into the attributes on that class. And if there happens to be a method named the same, for instance, first name, as one of the attributes on the underlying model, it gets run through that before it gets pushed into the underlying model. So that's what that does. And then the first proxy, the first metaclass here that we're going to run into is for the proxy. So there's a, and this is really just acting for, mostly for a little bit of utility. So every time we create a new class, there's a registry of all the known, all the proxies that we've ever created mapped to the object type for which they proxy. And then because we record that every time we create a new instance, there's this little convenience method that allows me to go in and say, you know, let me grab, like I have an object of this type, either what's the proxy type for that, or give me just a proxied wrapper around that specific object that I'm passing you, right? So the translator, as you can see, it's, like I said, it's designed to really focus in on one piece of the sort of pipeline of retrieving the information from the record, right? So this is for the JSON format. Of the two formats 5 slides ago, hopefully some of you remember. So as you see, it sort of binds to a model and it binds to a feed. So the feed is just an iterator to generate these records, right? And then each field that's decorated with the AppField Decorator, when we come back later and run through the translator, each field would get picked up and then passed along through to the underlying proxy object to set the values. So this is saying, go into my input and find the first name field, and then that will be returned and passed through the whole thing. And kind of the same principle for the get model instance. So to find the unique instance, we have to get, obviously, some data from the remote to sort of look it up. So that's what that's doing, too. So this is the AppField Decorator. All it does is, one, act as a flag. So the Metaclass that we'll look at next can pick up all the fields and record them for the class. And then also this simple single line of code to set the model instance's attribute of the name of the function to the result of calling the wrapped function. So, I mean, that's, if anybody's a little confused, we can come back later, but I think it's fairly all right. So, and here's the meta that I was talking about. So we come in and we run over all of the attributes that are coming in on this class definition, and we pull out every single one that is of the wrapped type and create a set of all those names that we then come back and reference later when we actually run through and translate these things. So you can see right here, if value name equals FieldWriter, so that's the function object that is coming into the Metaclass, right? That's actually getting the name of that function object, and because if you look in here, FieldWriter, right? So that's creating a set that contains all those names that then becomes an attribute on the class object, because this is a metaclass, and that's how metaclasses work, because we set ATTR's handler names to the handler names that we collected in this metaclass. And then we just go and do the metaclass thing and return the newly created type. So in the translator, there's a method called translate that uses those handler names that we picked up in the metaclass to iterate over all of those fields that were defined in the translator class. So there's no, like, basically, it's all the glue code, all sort of the flow control code stuck underneath the hood so that we don't have to rewrite it all the time. And that's what the translator is doing here when you call translate, and we'll see that later. And then we just, return the model instance. So we return the actual translated object as well. And then this is the FeedEater. So all the FeedEater is doing is binding the translator class, or is binding to a translator class, and then you call eat on it that runs over all the fields that we picked up in the Metaclass. And this, obviously, for more advanced stuff, there's more you can do in the FeedEater, like filter out some records while you're parsing through them, limit the number of records you're going through. But in the most basic case, all you're doing is binding this eater object to a translator. And then you just call eat, and you're off to the races. So here is the FeedEater. As you can see, the eat method, all it does is, there's some stuff ellipses in here, but mainly to get to the point. We pick up the translator class. We instantiate the translator class. And then we run over all the records in the feed, and we just we just call the translate method for each field. Or sorry, we call translate, which runs through all the fields, and then we save the record. So it's all sort of pulled together in there. And now I'll show you this. So here is, good. Is that big enough for everybody, or? Awesome. So here's what's in here. And this is what you get if you grab everything off the repo there. So as you can see right now, all that's in here is runpy, which is the classes we just ran through, the code we just ran through, sans the metaclasses and stuff, of course. And then 2 source files. So I'll just show you. So that's what's in that one, and that's what's in that one, right? So it's just 2 files that contain 3 users, 3 users each, one of which overlaps between the 2, just so that we can kind of see what that looks like. So now we're going to do, and actually run this guy. And now we're going to see we've generated all these files. So that's what's the model coming, generated through the Metaclass. And if we look in this, let me see, it's Robert Johnson, I believe. So you see, it's combined, it's normalized the data, so it's uppercased the name, and it's combined the data from the 2 different feeds into the 1 record. And yeah, that's where we're at. So, wow, yeah, that was faster than I expected. It always is when you're nervous. Yeah, so I guess I probably ran through that pretty quick. So probably some people have some questions. All right, I think you were first.
Sure. So why did you use metaclasses as your approach in this as opposed to just using regular subclasses?
Well, so you can't really do the kind of things that I was doing with regular subclasses. Like, for instance, the sort of thing like registering every instance of the class automatically, right? You'd have to call some register method on some, library or on some object that's like keeping track of everything, so that you could have that factory method, for instance. And also the magic of pulling out all of the field names and then creating this attribute on the class that knows all those names. Like, you can't really do that other than, I mean, I guess you could if you had some sort of, if you had to call basically more stuff that did that for you, but this automatically makes that happen for you.
Yeah, on a related note, why did you go with metaclasses
instead of class decorators? I don't know, I think they just look cleaner. There's less stuff you have to remember. I mean, kind of sort of tying those two, since it's related note, tying those two things together, like part of what I was going for and part of what I generally, when I'm thinking about writing a library, is trying to make sure that they're the fewest things that somebody can screw up solely by not knowing enough about the library or being lazy. So if you have to call a register method every time you take a class, or you have to remember to put a decorator on the class every time, it's that extra little bit of cognitive work that half the time somebody's going to forget, and it's going to mostly work, so they're not going to care. But I wanted it to fully work. So anybody else? Okay.
So instead of using getAtter, setAtter, did you look at descriptors at all?
So I have used descriptors before. Honestly, this is production code, so I wasn't like, hey, let me figure out every single feature I could use in the language. It was like, what do I want to do, and then how do I get there? Not, how can I make this really cool? But yeah, I mean, that's kind of the point of this talk again, is that this is code that actually runs and does something for us in the real world. So, Jesus. All right, anybody else? Go ahead. So I guess maybe I should have gone back to that slide. So like I said, I work at this Triplement. So we're a real estate firm, and we have like a StreetEasy Zillow style website for our users, and then a back office system for managing, for our agents to manage their clients and like everything they're interested in. So where this fits into our product is we ourselves do not collect listings from other agents. We use data providers who provide listings of apartments and houses and stuff for sale and for rent. So we have to get all of those records, and transform them into our data format so that we can stick them in the database. So that's where this fits in. This is the thing we use to to gather data from sources and stick it in our database. A day? On the order of tens of thousands a day. We have, I think, 200,000 listings in the site right now. Or, well, 200,000 records. They're not all currently active. But, yeah, I mean, the thing is, it's obviously not the maximally performant, if that's what you're getting at, because it's not like we have to do this in real time. We do this every couple of hours, right? So it's mainly about having code that runs fast enough and is easy to figure out where something is happening and sort of write another one, right? It's designed for discoverability over performance. Oh, sorry.
Do you have a single translator class, or can you have various translator classes that you basically just
Yeah. Yeah, so basically the way it works is you have your proxy class that sits in front of your model, and then that's pretty much, there's only ever going to be one for each model. And then you have a translator class for each record type that comes from a source, for each source, right? So if you're getting listings from 4 different sources, you have one proxy for your model in your database, and then you have 4 translators that feed into that from each of the different sources. Right, so the translator binds, again, to the feed that it is for, and then you bind that to the proxy that it feeds into. Anybody else? All right. Well, if anybody else, wow. If anybody else has any other questions or is interested in using or talking about or looking at this code, I am definitely interested in talking to you. So I guess that's it.